Hey friends, hello and welcome to my YouTube channel. My name is Aniket and I am here with you with a new video stating about vectors and matrices and their functions. But let us see what do we have in this video. In part 1 we will have a quick recap of the array and matrices. In part 2 we will come across the vector functions, the different functions which are used in the vectors. In part 3 we will see what are the functions that are used in the matrices, and also in part 4 we will do some hands-on on these functions of the vectors and the matrices. In the part 5 we will revise that what we have learned in this video. So what to wait for? Let's get started. In our previous video we talked about the two things, that is matrix and arrays. So regarding matrix, as you can see on my screen that there are 5 dimensions, that is data, nrow, ncol, byrow and dim names. And you can see the array functions in which there are 3 parameters, that is data, dim and dim names. Details of this you can find in my video whose link is given in the description. Let's proceed to the section 2. So starting with the vector function, the first comes as the ref function, which repeats a vector or a value at a given number of times. Next function comes as a sequence. So it creates a sequence of numbers starting from a given argument. The next function is the isVector function, which returns a boolean value true or false if the input object is a vector. Next comes as asVector function. It takes an object as an argument and converts it into a vector. Next comes as any function, which takes a vector and a logical condition as input arguments, checks the vector against the condition and creates a logical vector. The all function, elements in the logical vector are true and false if all the elements are not true condition and creates a logical vector. Lapply takes a vector list or a data frame and a function. It gives the result in the form of a list. The sapply function, it is similar to the lapply function, returns the result in a form of a vector. So now we will have a hands-on session on the different vector functions. So as we have come across all the vector functions, so let's start with the repeat function first. Suppose I have created a repeated vector with having a values as repeated vector angular braces hyphen repeat c 1, 2, 3, and I have used comma as 4. So this will repeat the values 4 times. So I will print repeated vector. So here you can see 1, 2, 3, 1, 2, 3, 1, 2, 3 has been repeated 4 times. Now I am taking the second parameter, that is I have created a repeated vector 2. In this I will create as repeat and then a vector function c 4, 5, 6, and I have used a parameter as length dot out equals to 15. So this length dot out will print the values as 4, 5, 6 15 times. When I will print repeated vector 2, it will give me the value as 4, 5, 6, 4, 5, 6, 4, 5, 6 15 times. Now suppose I created repeated vector 3. In this I am creating a vector repeat c 4, 5, 6, and I will use a function as each equals to 3. So this will print the values 4, 5, 6 3 times each. So it will repeat. Suppose I am printing repeated vector 3. Now it will print as 4, 4, 4, 5, 5, 5, 6, 6, 6. So these are the 3, that is for the repeat functions. Now we are coming for the sequence function. Suppose I create a sequence 1, sequence from equals to 2, 2 equals to 15, by equals to 0.5. It means it will print the value starting from 2 till 15 but with a difference of 0.5. Here you can see 2.0, 2.5, 3.0, 3.5 like this. Now suppose I create a sequence 2 and we have sequence function from equals to 5, length dot out equals to 12. It will print from 5 to till the length of 12, that is 5 to 12 is the 16, so 5 to 16 it will print. Now I have created a sequence 3 in which I will use a sequence function from equals to 5, length dot out equals to 12, equals to 20, and I think I have missed one parameter, that is 2, so 2 equals to 50, and then I will print this sequence 3. So it will print from 5 to 15 but the length will be 20, so it will expand those decimal values also, like 5, 5.52, 6.05, 6.57. It will divide accordingly and it will print the length as 20. Now coming to the next function, the is.vector function. Here we will use as is.vector and we are checking whether this sequence 3 is a vector or not. So it will give a boolean value that is true. This is how the is vector is working. Now we have a next function, that is matrix function. So this will convert any vector to a matrix form. Like suppose we have created a mat2vec and a matrix function here, and then we have given the data as 1 to 9 and it will arrange the data as in the 3 by 3. So when I will print this mat2vec, it will give us 1, 2, 3, 4, 5, 6, 7, 8, 9. So it has divided. And now I have to find the data type of this. So for finding the data type, we will use a class function which will give us the matrix. So this proves that the mat2vec is a matrix data type. Now suppose we have used a mat2vec and we have to use a as vector. So this will convert the matrix to vector. So as dot vector will print the vector form of that. So it has printed as a 1, 2, 3, 4, 5, 6. Now when I will see the class, it will give us integer. Yep, see, integer is coming. So this means that matrix is a different data type in R. Now suppose we have created a vector which is data type as integer. As dot integer creates a vector having integer data type. So the values are suppose 34, 23, 53, 42, 16, 42, 64 and 70, 32 and 76. So we have created this vector. Now we are using any function for this vector. We have used any, then vector name, and then the logical operator, that is values which are greater than 50. So it has given us true. I will explain you why it has given us true. Now suppose we are using all functions. So vector greater than 50, it is giving us false. So for any one of the value which is greater than 50, it is giving us true. For all the values are not greater than 50, that is why it is giving us false. So this is how all and any works for the vectors. Now suppose we are creating a vector whose name is names, and here this is a string data type which is having John, then there is a value as Rick, and then we have Rahul, and the next value is Abdul. So what I will do is that I will use lapply function. So it will print the values in the form of the list. We are using toLower function which will convert the case of these values, and here you can see all the values are coming in the lower cases in the form of a list. Now suppose we have created a sapply function. For the sapply function we are using the names vector and also a toLower function. So this will give us in the form of a vector. So John, Rick, Rahul, Abdul are given in the form of this vector. So this is how the functions are in vectors. So let's have a discussion on the matrix functions. So regarding the matrix function, the first is the is matrix function, which returns true if the object is a matrix. The next function is percentage into percentage. This is a matrix multiplication with the percentage into percentage operator. It will multiply the matrix. The next function is the solve function, which is inverse as the output, means matrix inverse as the output. Next function is the transpose function, which is the transpose of a matrix, as we have learned in the mathematics. We will come to that. The next are the dim and dim names. So dim shows the dimensions of the matrix. It can also change the dimension of the matrix and convert vector into matrix by giving its dimensions. Dim names are the names of the rows and columns. C-bind and R-bind. C-bind function joins two or more matrices. Column and R-bind binds the matrices in the form of the row. Can extract or replace a diagonal of a matrix. Can also construct a diagonal matrix. Determinant function returns the determinant of the input matrix, as that we have learned in the mathematics. Call sums returns the sums of each column. Row sums function returns the sum of each row. Sum function returns the sum of all the elements. So, and call means, row means and means are same as the what we learned in the row sum and the call sums and the sum function. It will give us the mean as the output. So let's have a hands-on on the different matrix functions that we have learned in this section. So let's start with the functions that are used in the matrix. So suppose we have created the 4 matrix, that is matrix 1, which is a 3 by 3 matrix having elements as 1 to 9. We have also created matrix 2, which is having these values 3 2 0 0 1 comma 2 2 minus 2 comma 1, and this is also a 3 by 3 matrix. We have also created a matrix 3 and matrix 4, which is a 3 by 4 matrix. Here as you can see, that is matrix 3 is containing the value as 1 to 12 and matrix 4 will be containing the value as 11 to 22. Now I will print this matrices to see how it looks like. So suppose matrix 1 looks like this, matrix 2 is also looks 3 by 3, matrix 3 is a 3 by 4. Oops, I think screen is not fitting, so I have to clear the screen, and once again I have to print all the matrices to display to check. So suppose matrix 1 look like this, matrix 2 is 3 by 3, matrix 3 is looking 3 by 4, and matrix 4 is also looking good, which is a 3 by 4. Now we will have a operation all these matrices, but first we will have a multiplication of matrices of matrix 1 and matrix 2. Now let us see how matrix 1 and matrix 2 looks like. And if we use element multiplication, then it will multiply the elements, that is 1 into 3 it gives us 3, 4 into 0 it gives us 0, 7 into 2 it gives us 14, 8 into minus 2 gives us 16. So this is a element by element operation multiplication. So now if we want to multiply the two matrices, not the element wise, but the matrices should be multiplied. So this can be achieved using percentage star percentage function. So this is something like we have to use matrix 1 percentage star matrix 2. It will multiply the matrix as per the rules that are defined in the mathematics. You can try yourself also manually in your notebook and check whether the values are okay or not. So now if you want to find the inverse of the matrix 2, this can be achieved using the solve function. If we will print this inverse of matrix, it will give us the value something like this, which is matrix 2 was looking something like this. You can try it yourself manually and find by using the appropriate steps which are defined in the mathematics. Now if you want to print the transpose of matrix 1, we can use T function, that is T bracket mat1. Here you can see that the elements are being transposed. that is columns have been converted to rows and rows have been converted to columns. So this is how the transpose function works. Now if you want to find the dimension of any matrix, we can use the dim function, that is dim matrix 1, which is giving as 3 by 3, that is 3 rows and 3 columns. Now if we want to convert the structure of the matrix, we can use dim function matrix 1, then we have to use the C, the 9 comma 1. This will convert a 3 by 3 matrix to 9 by 1 matrix. So this is how you can convert the structure of a matrix. Now suppose we have created two vectors, which is R names and C names, that is row 1, row 2, row 3, R names elements, and C names is column 1, column 2, column 3 elements. Now why these are used? These are used to rename the indexes of the matrices. So we have used dim names. Dim names is the renaming of the column indexes. Matrix 2, then list R names comma C names. So now if you will print mat2, you can see here the values are coming as row 1, row 2, row 3 and column 1, column 2, column 3. Now the numbers are not being shown, only the values. Now we have a matrix 3, which is a 3 by 4 matrix, and we have used a cbind function for the matrix 3 and matrix 4. So here you can see cbind stands for column binding, so it has extended the number of columns, but the number of rows is fixed because cbind combines the columns itself, not the rows. Now if we are using the diagonal of the matrix 3, then it is giving us the diagonal elements, that is 1, 5, 9. Suppose we have to print the diagonal elements in the form of a matrix, we can use diagonal, then matrix 3. So it will print the matrix form of the diagonal elements. Now suppose we have to find the determinant of matrix 2, it will calculate the determinant using the det function and it will give the value as 10. Now suppose we have to find the sum, then column sums for the matrix 3 can be calculated using call sums function. Sums for the row elements can be calculated using row sums, then the matrix name, and when sum of each element can be used using the sum function. Here you can see the 3 sum functions. Same stands for the mean function. So mean as per the column basis, means as per the row basis, and means for all the elements for the matrix 3 will be shown like this. You can calculate from yourselves. So these were the functions for the matrices. Thank you and have a nice day.